Hey everybody, welcome back to another fun and exciting pre-calculus class. Today we will be jumping into lesson 6.5, talking about double and half angle identities. Basically, we've been talking about identities here for the past several lessons, so we'll be continuing in that. Maybe you're kind of feeling frustrated right now just with the way things are going and you're not understanding and you're having a hard time. Hopefully this lesson will be a little bit easier for you. I think you'll be able to handle this one if you pay attention and if you work through these problems with me. Okay. So what is a double and half angle? Well, if you look in your book, we'll kind of go over there and take a look at page number 125. A double angle and a half angle. A double angle is like taking an angle and multiplying it by 2. The other one, the half, is you're cutting it in half. There's something that corresponds here, and that is using 2. So you're doubling it or cutting in half depending on what you need. Now, why would you need it to be doubled or to be cut in half? Well, the idea is that if you double it or if you cut it in half, you would be using an angle that you know. For example, a 30-degree angle, a 60-degree angle, a 45-degree angle. You're taking it to something that you already know that's part of the unit circle. Kind of the same idea with adding the two angles to get, or subtracting the two angles to get one that you know. Now we're going to just double them or cut them in half. All right, so basically it's the same thing, but there are some differences. So the double angle identities. Now I'm not going to show you this whole thing as far as delineating the whole deal. But what's going on here is they're saying, look, it's the sine of the double is the same as sine of theta plus sine of theta. Remember when I just told you a second ago, it's almost the same thing as doing the addition and subtraction, and it really is. The only difference here is that they're the same. So it's 2 of theta. So it's not a theta and a phi, it's 2 of theta, 2 of the same angle. So that makes it a little bit easier. We don't have to use this. That's great because we don't have to plug it into that. It makes it a little bit easier. What they've done is they've simplified it right here. So they basically do this, but because everything's theta, they can combine things. And you end up with 2 sine theta times cosine theta. Okay? If you look down here, table H, this is where they show it to you, the simplified version. They don't show you all this up here. They just simplify it. 2 sine theta equals 2 sine theta times cosine of theta. Cosine of 2 theta equals cosine squared of theta minus sine squared of theta, and so on. There's multiple ones you can use with this because basically you're using different identities to change the formula just a little bit. Which one would you use? You can use any of them. You would use the one that's easiest or that fits into what you want to do. Then this last one is when you're using the tangent. So tangent 2 theta equals 2 tangent theta over 1 minus tangent squared of theta. So make sure that you, let me scroll up there. So make sure that you take a look at that. Table H, very important table that you're going to need for this. All right, so here's the example number 1. Find the exact value of the 6 trigonometric functions of 2 theta given that cosine of theta equals 3/5 for the 4th quadrant angle theta. Now, one thing to be careful of right here is that you don't come into this like with a preconceived notion. And that is that, oh, I'm in the 4th quadrant, so cosine must be negative. Well, look right here. It says that the cosine theta for 3/5, it shows it as positive, and we're in the 4th quadrant, so it should be positive, right? Well, not necessarily, because we're dealing with a double angle right here. We're dealing with a 2 times theta situation. So what's going to happen is it's like you multiply a negative times a negative, and what do you get? A positive, right? So these are going to come out the opposite of what you think they are because you're dealing with a double angle, okay? So just work them out. I'm not saying don't use all students take calculus because we're going to need to in just a second, but don't come in there with a preconceived and say, oh, So I know which one this is going to be because we're in the fourth quadrant. So that means that sine's going to be negative, cosine's going to be positive. That's not true with these double angles, okay? So I've got this written over on this screen. So let's jump over here and let's talk about this. So here's the formulas again. These are the double angles. These are the half angles, okay? We'll get to half angles in just a second, but let's focus here on the double angles, okay? So I've written the question, and then over here to the right, I've written the sine, the secant, the cosecant, cosine, all that stuff over here. So we'll just write our answers as we go. As we get one, we'll write the next answer. As we get the next one, we'll write the next answer. Um, let me tell you something right here. This is true for a lot of these. If you have a calculator, like the calculator that I have, okay, so if you've got one that's like a graphing calculator or it's an advanced scientific calculator, you can put these into your calculator. It'll give you the answer, okay? However, you need to know how to do these, so don't take that. That's a cheat, okay? Don't use that cheat because yes, you can get the right answer, but you didn't do it. So if I have students on a test, I need them to submit their work to me so that I can see they know how to do it. So don't take that shortcut because I've been telling you this all along, but when we get to next chapter, chapter 7, you're going to need to know how to do this. So don't take that cheat, please, okay? Work these out, do it the way that you're supposed to do it, do the way the book is showing you to do it, and you will have greater success in next chapter when we get there. All right, so here we go. We have the sine of 2 theta, and what we've got going on here is we've got the cosine of theta is 3 over 5. Now that's the cosine of theta, not the cosine of 2 theta. So you might be tempted to come over here to this cosine of 2 theta and just write it in. Or you might say, well, I'm just going to double it, so I'm just going to put 6 over 10. That's not going to work either, okay? It's not the way this works. So be careful on some of this, that kind of think through it and you do it the way that the book is showing you to do it. All right, so the first thing that we want to do is we want to take this and we want to plug this into our first identity. So what's our first identity? So the sine of 2 theta is equal to 2 sine of theta times cosine of theta. 2 sine theta times cosine theta, okay? Now again, you might be thinking, oh look, I've got the cosine of theta, let me just plug it in right there. You can do that, but let's wait for a second. We're going to plug it in just a minute, but let's do something else first. From our Pythagorean identities, we know what the sine of theta equals, okay? And remember, we're trying to always take them to one thing. So right now you have sine and cosine. You're always trying to take them to one, sine or cosine, or you're always trying to get them to be alike so that you can solve them out. So if we say that our Pythagorean identity is that sine of theta equals the square root of 1 minus cosine squared theta. Don't forget that this is a plus minus in the formula. So which one are we going to use? Are we going to use the plus or the minus? This is where we go back to this right here. Cosine of theta is in the fourth quadrant. So is sine positive or negative in the fourth quadrant? Sine is negative in the fourth quadrant, so we're going to use the negative. So let's go ahead and get rid of that positive, and we're going to use that negative because sine is negative in the fourth quadrant. Okay, now what? Well, now we can go ahead and we can plug into this right here, and we can say, okay, we know what the cosine is, and the cosine of theta is 3/5. So let's go ahead and plug that 3/5 into that. So now we have minus the square root of 1 minus 3/5 squared, okay? And so basically we've taken this and we've substituted in. So what is that? Well, we just square that. So we get the negative square root of 1 minus 3/5 is 9 over 25. So then we would take that 1 and we make it a common denominator. So the square root of 25 over 25 minus 9 over 25. Still negative out front there. And we would get what? Well, we would get 24 minus 9 is 16. So square root of negative 16 over 25. So we can solve that one out, right? So we get negative 4 over 5. The square root sign goes away because we square rooted the 16 and square rooted the 25. It goes away. So that is our solution, yes and no. That is the sine of theta. Okay? So our sine of theta, that's not, now go back up here. That is not the sine, the 2 theta. That's just our sine of theta. So now what we have to do is we have to plug it back into this original equation in order to get what the 2 sine is, because this is our 2 sine identity, right? This is the formula for our 2 sine identity. So let's go ahead and plug it in. So we're going to have 2 times negative 4/5, throw that in parentheses, and then times, going back to this, times our cosine of theta, which again is up here, and that is our 3/5. So times 3/5. And then you're just going to do that math, okay? So put that as a fraction and just work your way across. So 2 times 4 is 8. 8 times 3 is 24. This equals 24 over 1 times 5 times 5. There's a negative here, so this fraction is going to be negative, and that's going to give us 25. So that is the solution to the sine, the 2 sine, the 2 theta double angle is minus 24 over 25. Negative 24 over 25. That's our sine. Okay. Now we're ready to find the cosecant. Why? Because cosecant is just the flip. It's the inverse of sine. So very easily we can just say negative 25 over 24. Now we have a problem, and that is we can't really go any further because we need the, see, we have the opposite over the hypotenuse, right? This is the opposite up here. This is the hypotenuse here, but we need the adjacent. So we don't have the adjacent leg. So how are we going to find the adjacent leg? You might think, oh, I'll just plug it into the Pythagorean theorem. That will work. It won't work here. It will and it won't. It won't work here because remember, we're in the double angles. And so I guess if you doubled the Pythagorean theorem and you kind of worked it like that, I guess you could get it that way. But the easiest way to do this is just to come down here and we're going to just plug it back in. We're going to plug in for our double angle identity. So if we go to cosine, so now we're looking for cosine. So we need to pick one of these. All right, so let me do this. So cosine of 2 theta, that's what we're looking for right now. So how do we do that? Pick one of these, choose one of these that works with the information that you have. All right, so what's one that works with the information that we have? Well, really any of them would work now because we have the sine, so we could do that one. We have the cosine, so we could do that one. And here we have the sine and the cosine. So we really could work with any of those. You just kind of pick which one maybe you like the best or which one that you want to work with. The book chooses the second one, so we'll choose the second one. We really could work with any of them, but we'll choose this one. So the cosine of 2 theta equals 2 cosine squared theta minus 1. Okay, so let's go ahead down and write that. All right, so I've got it written down here. Remember, now we just need to plug into this. So we're going to do cosine of 2 theta. That's what we're looking for. Equals 2 times what? Well, what is the cosine of theta? Well, we already had it up there, and it was 3 over 5. And that is quantity squared minus 1. Just work this out now. 2 times, we'll square that quantity. That gives us 9 over 25 again. We've already done that once. Minus 1. And then we're just going to I think probably multiplying this is the best way, just in a fraction. So you get 18 over 25 minus 1, and then we get 18 over 25 minus 25 over 25, because we're trying to get the common denominator, so we turn that 1 into a fraction. And then we just subtract that. You say, I can't subtract that. Well, yes, you can. So you just follow your rules. So 25 minus 18, that gives us 7. And so we take the sign of the largest. So the sign of the largest is the 25. So that's going to equal negative 7 over 25. Okay, so that is our cosine 2 theta, negative 7 over 25. So negative 7 over 25. Now we have everything that we need to fill in the rest of them. We don't even need to do anything else because we already have it. So we have the opposite, we have the hypotenuse, and now we have the adjacent. All right, so you just fill everything else in. So the secant is just flipping that. So that's going to be, the secant's going to be negative 25 over 7. Now the tangent is opposite over adjacent. So the opposite was 24. So 24 over, and that was a negative 24, right? So we'd have negative 24 over negative 7. So that's going to be a positive one. So negative is going to give us positive, and then so cotangent would also be positive here, 7 over 24. And that's basically all we would do for that. There's your solutions. Go ahead and turn in your book to page 126. 126. We're now going to do half angle identities. Half angle identities are really very similar. They just, instead of doubling, now we're dividing by 2. So multiply by 2 for double, divide by 2 for half. Pretty simple. And we have basically our chart's going to change, and they delineate them right here. You can look at that, and then the chart is on 127. Look at page 127. And so you have your chart right here, half angle identities, and notice how this one is the tangent one, where it kind of comes up with multiple ones that you can use. And again, you can pick there which one works best for you based on the information that you have in the problem. All right, so now the probably the trickiest part of this one is going to be where it says find the exact value of tangent of 157 and 1/2. Now, you might be thinking, wait a second, I thought these were half angle identities. They are. Now, and this is kind of the weird part. What they're asking you to do is not take half of this, okay? They're saying, like, look, if this is your angle that you have, let me show you something really quick right here. If you have a calculator like mine, remember I told you that you can just plug this in. So let me show you that this actually does work. So look over here at this, and if I type in the tangent of 157.5, 157.5, it's going to give me an answer. And that answer is the correct solution, actually. Now, my calculator does not give me that in exact value. So that's a problem. So maybe if you're thinking, boy, that'd be easy if I could just do that. It won't give it to you in exact value, but this value that it gives you is the correct answer in a rounded off decimal. Okay, so your calculator will help you, but it won't totally solve what you need it to solve right here. So if we kind of go back and look at the book again, what we need to do is we need to plug these into the identities that we were given on the up here in table 1, and go from there. Now look, when you get this, the tangent of 57.5 is the same as half of 315. How do you do that? Well, you just take 157.5 and you double it. 157.5 times 2 is 315. Why are we using 315? We're using 315 because if we come over here and look at our unit circle, we're using 315 because 315 is one of our solutions on our unit circle. Okay, so in other words, that's a 45-degree angle right there. 45-degree reference angle. All right, but we're in the fourth quadrant, so you could kind of note that we're in the fourth quadrant. So let's go ahead and go to this, and let's just kind of work through this. So if we have the tangent, okay, so go back up here to the half angle formulas. So we have the tangent, right? So what are we looking for? Well, we're looking for, it wants you to find the tangent, and I think the other one was the sine. I think the sine. So those are the two that we're going to need. We're going to need tangent, so this one right here, and we're going to need sine. And their half angle formulas are a little different. So you can use, what these are is these are just different. This one is the squared version. If you ever have square, this one is the regular. So you can do different ones. The ones that I'm looking at here are different. The ones in the book, you can look through the ones that you need. All right, so let's go ahead and pick the one that we need. Let's do tangent first. So we'll use this one here with the 1 minus cosine of theta. All right, so let's go down here and let's write that. So our formula is tangent of 157.5 equals. And now we're going to want to write the formula that we find in the book, and the formula is plus minus, and we'll talk about what we're going to do with that here just in a second, 1 minus cosine of 315. Where did we get that 315? We got it from this. We took the half of, we doubled that. So in other words, we're taking the half of this one right here. Okay, so what you do in these formulas is you take the angle that you have and you double it and you put it here, because here is where you're doing the half. Don't take half of this. That's kind of the trick right there. Don't take half of that. Take half of this, or really double this is the way it's done. All right, and then the bottom would be 1 plus the cosine of 315. Now we know the cosine of 315, it's on our unit circle. We can jump back over there. The cosine of 315 is negative square root of 2 over 2. Negative square root of 2 over 2. So come back in over here, and we are just going to go ahead and do that. So, well, let's do this first. Do we need the positive or negative? All right, so this is kind of tricky because you're thinking, well, tangent, we are in the 157.5, but we're using the half identity here, so we're using the 315. So which one is it? It's this one. We're using the original. So which quadrant are we in there? We're in the second quadrant, so we're going to use the negative because tangent is negative in the second quadrant. So we're going to use negative square root of 1 minus square root of 2 over 2. Because that is the cosine of our 315-degree angle, over 1 minus the square root of, actually 1 plus, sorry, square root of 2 over 2. Now we just want to solve that out, make them same denominator, right? And then just try to cancel what we can cancel. So what are we going to have here? Negative square root of, so what I did was I just took the 1 and I turned it into a denominator with 2. That way I can actually subtract that. So what do I get here? The way that you could do that is really you don't get anything. You get the same thing. But let's put it over one denominator, right? So we're going to do it like this. We're going to do 2 minus the square root of 2 over 2. And that's simplifying it just a little bit. It's not super simplified, but then 2 plus the square root of 2 over 2. Now what we need to do is rationalize this denominator. Okay, so hopefully you remember how to rationalize denominators because we have that square root right there. So we need to multiply by the conjugate. So here in the numerator, what you're going to want to do is, because we're inside a square root sign, right, we're just going to continue to write 2 minus square root of 2 squared. I'm going to show you what happens with that. It's kind of cool what goes on right here, because we have a square, right? 2 minus square root of 2 times 2 minus square root of 2. What you can do with that, and I think right now what I would do is I would just break this down to where you put this, and you kind of take it out of the square root. So you just square root the numerator and you square root the denominator. I think that's going to be a little bit more helpful right here. So when we do that, check out what happens with this. This just cancels, okay? And we're left with 2 minus the square root of 2 in our numerator. So we eliminate our square root with our square. Those cancel. In the denominator, look what happens. So in the denominator, we're just going to FOIL this, and the denominator comes out with, remember whenever we have conjugates, right, it's going to cancel the middle terms. So we really only need to FOIL the first and the last. So we're FOIL the first and we get 4. We FOIL the last and we get minus the square root of 4, which is 2. So 4 minus 2 is 2. So our denominator down here is going to be the square root of 2. Now it stays in the square root of 2, right, because we haven't solved that out yet. This one came out of the square root sign. The denominator did not. All right, so now what do we have to do? We have to simplify it again. So now we have to multiply by the square root of 2, both of those. And we're going to get, on the bottom, we're going to get the square root of 4, or we're going to get 2 on the bottom. And then on the top, what are we going to get? Well, we're going to get 2 square roots of 2 minus the square root of 4. And then just simplify that out. So you get 2 square roots of 2 minus 2 over 2. And then we can cancel. Well, technically, we have to factor this 2 out. So we'd get 2 square root of 2 minus 1 over 2. That's going to cancel. Finally, we are done with that. Our answer would be square root of 2 minus 1. Okay, so the tangent of, going all the way back up here of 157.5, square root of 2 minus 1. I won't take the time to show you, but we would do the same thing with the sine. We would take the sine, we would plug it into our half angle identity, which is right here. And then we would, do the cosine of 315, because remember, you double it. Okay, so you double this sine of 157 and you get the cosine of 315. Work it the same way. Really what this is in a way, it's an exercise of you rationalizing denominators and you multiplying and FOILing and all that stuff. So these are things that you should be able to do, but it does take time. All right, obviously with this video, it just took me time to get through everything. But as far as being challenging for you, it shouldn't be too bad because you know how to do most of this stuff. It's just, this lesson is just plugging into formulas. That's it. Plug into the formula, work the formula, and don't break any math rules. Okay? All right. Well, that's all I got for you. Hope you enjoyed it. If you missed anything, slide it back, take another look at it. We'll see you later. Have a good one. Bye-bye.